Hi and welcome to an overview on factoring common factors. Before we start, a couple of reminders. For me at least, the idea of factoring can be most simply thought as reverse distribution. And since I'm big on arrows and rainbows, for me I really just think of anti-rainbowing, and I hope that'll be clear as we go along. Another distinction is to make sure we're clear on what a common factor might be versus the greatest common factor. So let's begin with an idea of how we create the problem in the first place. If I had something nice and simple like x plus 2, and I was to multiply onto x plus 2 the number 3, this is where we distribute. So most of us have learned over the years to put a little rainbow in here and consider 3 times x gives us 3x, and that 3 times 2 gives us, oops, sorry about that, gives us 6. Now, if we were presented originally with just 3x plus 6 and someone asked us to factor it, the question they're asking is, well, what could you take out of each of the two elements that would be common? Something that you would have multiplied onto each of these two pieces to get 3x plus 6. So I tend to think of this, the question as being, well, how could I anti-rainbow my 3x plus 6? What could I take out of each one that would be the same? And in that slot, I begin to think, well, there's a 3 there and a 6, so there's something similar about the 3 and 6. I believe that 3 times 2 is 6, so I could take out a 3 as I go. Now if I do that, I then have to answer the question, well, what is it that I would multiply onto right here to get 3x? And the answer, of course, is x. And then my next question is, well, what would I have rainbowed or multiplied onto over here to get 6? And that's 3 times 2. And so we can see now how this idea of distribution and anti-rainbowing are really just the same process in reverse. So if that's helpful to you, I hope that will make some sense. Now 3 in this case is a common factor, and in fact it's the greatest common factor as well. In a few of our examples coming up, you'll see how that can change when there are more opportunities. And here's our first proper example. Let's consider 8x squared plus 4x, and imagine what we would have multiplied onto what to get 8x squared and 4x. Let's start simple with a factor. Let's think of one thing we could have multiplied onto 8x squared and onto something to get 8x squared and onto something to get 4x that would be the same. And let's go for something that looks fairly straightforward. We have an x here and an x squared. So it looks like I could have multiplied x onto something here and x onto something there. So let's start with that idea. Let's put an x here. Now I would have multiplied x onto, it looks like 8x would do the trick right here. Let's double check that. If I multiply 8x times x, I get 8x squared, so that looks pretty good. And then I would have multiplied x onto 4, it looks like. So that would give me very nicely 4x. So that is a factor, and that was a variable factor. Let's look for a constant factor of 8 and 4. And it looks like I could use 2. I could multiply 2 onto something there. So let's try 2 in here. And what kinds of things could I multiply 2 times to get 8? Well, let's see, that would be 4. So I could have a 4x squared, and let's double check again. 2 times 4 is 8. 8x squared, that looks pretty good. And then 2 times something to get 4, that's going to be 2. And the x comes along for the ride. So there's 2 times 2, which is 4x. So that looks good. These are both examples of common factors. Now it does look like I could have taken an x out of here as well in the second part, and even an additional 2. So maybe we could try for the greatest possible common factor. And it looks like I can only take a full x out of both of them. So let's start with that idea. That would be maybe the best that I could do, would be to take an x out of both. And then let's consider the 4 and the 8. I guess I could factor out a 4 from both of them. And that would leave, finally, in the middle here, that would be 4 times 2 gives me the 8, so I'll have a 2 there. And x times x will give me an x squared. So let's check. 4 times 2 is 8, x squared, that looks good. And then the second piece over here, wow, I think I've got everything, so it's just a 1. And so when I put in my 1 there, I think we're all done. And now, that means that 4x is called our greatest common factor, while x and 2 are both considered factors. Well, and now we'll go for a more complicated example, and I would encourage you to press pause for a moment and imagine how you might factor this with the greatest possible common factors and what might be also just possible common factors. So give that a go and then press play again. Now I imagine you're back now, or you've decided just to go for it. So let's take a little look here. We've got 8 and 4, and I think we worked on that before. So the greatest possible common factor would be 4 out of 8 and 4, while 2 would have been a common factor. So let's see if we can't just kind of go for the whole ball of x here. If I'm going to anti-distribute here, looks like I could pull out a 4 from both of these, and that would leave a 2 in the first case and a 1 in the second case. And 1 is always a little bit dangerous because it can turn into other things, but alright, let's see. So then here's an x to the 2, which is really x times x. This is now x to the 5, which is x times x times x times x times x. So it looks like we could anti-multiply or anti-distribute 2 x's. So we could take an x squared and anti-rainbow it. Now therefore we're out of x's, so we don't even need anything there. And then we have still 3 x's left here. And so we'll put in x to the 3rd. And then we'll take a little look here, y squared and y cubed. Looks like we can take out a y times a y, or rather y squared. And that would leave us, if say we're going to rainbow onto what? To get y cubed, that's y times y times y. Here's 2 of them, so I need one more y sitting right here. And then y squared onto here, that would give me everything I could possibly want. So let's rewrite this a little bit tidier, and then we're going to double check it to make sure it really worked. So here is 4x squared y squared times 2y plus x cubed. And now we've tidied up that 1 by multiplying it on to x squared, x cubed. So let's check. Let's try a little rainbow and make sure that this really does work. If I take 4x squared times y squared and I multiply that onto 2y, that's going to give me indeed 8x squared, and then y squared times y is y cubed, and then the second half of my distribution is right over here, and that's going to give me indeed also 4, and then x to the 5th, and finally y squared. And that is a great introduction to basic factoring for greatest common factor and for also common factors. Hope you enjoyed.